What up, Condors? It's your boy, Mr. Roberts, here with a little social distancing science for Friday, April 10th. Hey, before we get started, don't forget to hit that subscribe button and turn on notifications so you don't miss any of my social distancing science. And I'd appreciate it if you gave this video a thumbs up if you like it. Okay, we are on the assignment read about why do Earth's seasons change as Earth orbits the sun. We've got 5 little things we're going to do today. Shouldn't take us too long though. Now you might think that the summer occurs in the northern hemisphere when Earth is closest to the sun, and winter occurs in the southern hemisphere when Earth is furthest from the sun. However, seasonal changes do not depend on Earth's distance from the sun. In fact, Earth is closest to the sun in January. Instead, it's the tilt of Earth's rotation axis combined with Earth's motion around the sun that causes seasons to change. Now, during one half of Earth's orbit, the north end of the rotation axis is away from the sun. Then the northern hemisphere receives less energy from the sun, and the southern hemisphere gets more. Temperatures decrease in the northern hemisphere and increase in the southern hemisphere. This is when fall and winter occur in the northern hemisphere and spring and summer occur in the southern hemisphere. And then during the other half of Earth's orbit, the north end of the rotation's axis is towards the sun. This means that the northern hemisphere receives much more energy from the sun than the southern hemisphere, leading to summer in the northern hemisphere and winter in the southern hemisphere. Okay, we're going on to 3D thinking. Why do Earth's seasons change as Earth orbits the sun? Can you convince my computer to work faster? I know I've tried. Okay, how does the varying amount of sun's solar energy cause the seasons? What effect does the tilt of Earth's rotation axis have on the seasons? Pause this video, answer it. When you're done, come back, hit play, and we'll go on to the next thing. Which is, read about what is Earth's seasonal cycle? You've learned that as Earth travels around the sun, its rotational axis always points in the same direction in space. However, the amount that Earth's rotation's axis is toward or away from the sun changes. This causes changes in a yearly cyclical pattern. Now, there are 4 days, count them, 4 days each year when the direction of Earth's rotation's axis is special relative to the sun. A solstice is a day when Earth's rotation axis is the most toward or away from the sun. An equinox is a day when Earth's rotation's axis is leaning along Earth's orbit, neither towards nor away from the sun. When you read The Great Gatsby, Gatsby says that he always wishes that he had thrown a solstice party. So now you'll know what that is. So, when the north end of the rotation axis gradually points more and more towards the sun, the northern hemisphere gradually receives more solar energy. This is the spring in the northern hemisphere. Then we have the June solstice to the summer equinox. The north end of the rotation axis continues to point towards the sun, but does so less and less. The northern hemisphere starts to receive less solar energy. This is summer in the northern hemisphere. Then we have the September equinox to December solstice. The north end of the rotation axis now points more and more away from the sun. The northern hemisphere receives less and less solar energy, and this is fall in the northern hemisphere. Then we have December solstice to March equinox. The north end of the rotation axis continues to point away from the sun, but does so less and less. The northern hemisphere starts to receive more solar energy, and this is winter in the northern hemisphere. So the figure below is going to show us how the sun's apparent path through the sky changes from season to season in the northern hemisphere. The sun's apparent path through the sky in the northern hemisphere is lowest in the December solstice and highest on the June solstice. Let's click on these buttons. Okay, so in the March equinox, see where it is. That's pretty south. Oh, it's a little further north. Oh, wait. The equinoxes are in the same spot. And then if the June solstice is the highest up, what do you think the December solstice is going to be? Ooh, the furthest down. Now, the seasons change as Earth moves around the sun. Earth's motion around the sun causes Earth's tilted rotation axis to be leaning towards the sun and away from the sun. Let's take a look at another image. Okay. So in the December solstice is on December 21st or 22nd. On this day, the north end of Earth's rotation's axis is away from the sun. The days in the northern hemisphere are the shortest and nights are the longest, and winter begins. And days in the southern hemisphere are longest and nights are the shortest. Summer begins. Okay. September equinox is on September 22nd or 23rd. On this day, the north end of Earth's rotation axis leans along Earth's orbit, and there are about 12 hours of daylight and 12 hours of darkness everywhere on Earth. In the northern hemisphere, it's the beginning of autumn, and in the southern hemisphere, it's the beginning of spring. Let's go to the March equinox. So the March equinox happens on March 20th or 21st. And this is again about 12 hours of daylight and 12 hours of darkness everywhere on Earth. Spring begins in the northern hemisphere and autumn begins in the southern hemisphere. And we have the June solstice. The June solstice is on June 20th or 21st. On this day, the northern end of Earth's rotation axis is towards the sun, and days in the northern hemisphere are the longest and nights are the shortest. It's the beginning of summer. That would be the summer solstice party that I was talking about earlier. Okay, one more thing. Let's go on to a little 3D... Oh, I'm sorry, a little close reading, actually. Meteorological versus astronomical seasons. So, astronomical seasons, which are based on the position of Earth in relation to the sun, differ from the meteorological seasons. Let's read to find out why. Okay, we've got an article here. I want you to read this. And can you highlight the most important things? I'm not going to read this to you today. I'm going to let you read it. Unless we want to let the computer read it. Okay, so read this. And we'll go on to our last thing, which is a 3D thinking. What is Earth's seasonal cycle? Okay, when the northern hemisphere is experiencing summer, Earth is the furthest away from the sun in its orbit. That distance is 152 million kilometers, and that's called the aphelion. Approximately how far from the Earth is the sun in miles? Let's see if we can convert this. So we know that if we multiply the distance in kilometers by a conversion factor of 0.62, that will give us the number of miles. Can you figure out the aphelion and the perihelion in miles? Answer those, and then we'll go on to the next one. Now, if the shape of Earth's orbit was unaltered, but the rotational axis was tilted so that we didn't have any tilt with respect to the orbit, what do you think that would do to the seasons on Earth? Answer that, and we're done for today. Have a great weekend and a great spring break. I will see you all back on Monday the 20th, I believe. Yeah.